This is my 7th video lesson for the Ionic Bond unit. In this lesson, we'll be learning how to name ionic compounds. So go to page 22 in the class packet. For motivation, you know that NaCl is sodium chloride. Based off of this, what can be the possible naming rules for ionic compounds? Learning target. At the end of the lesson, I will be able to name ions and ionic compounds. For homework, do number 7, which is a junipod. Names are quite important. They're used to identify things or people. So scientists develop a strategy in naming things. This is called nomenclature. In biology, there's a system of naming animals based off the genus and the species. So by looking at the name, you can identify the animal and see how it is related to other animals. In chemistry, the rules for naming is developed by the IUPAC, which stands for the International Union of Pure and Applied Chemistry. If you see this on the regions, it basically means this and refers to the rules of naming. So why develop the system of naming? If there is no system of naming, then each chemical compound has a unique name. And since there's infinite amount of chemical compounds in this universe, that is a lot to memorize. It's much easier to memorize 10 rules than a trillion different names. In addition, if you have a system of naming, you can tell how one chemical compound is related to another and what elements or bonding is present in that chemical compound. So let's start with the rules for naming ions. For metal ions, which are positive, you keep the element's name and you add the word ion. For example, if potassium has a charge of positive 1, that is potassium ion. For nonmetal ions, which are negative, you change the element's base ending to IDE and you add the word ion. For example, this fluorine has a negative 1 charge. You have to change the ending of fluorine to IDE, so that becomes fluoride, and then you add the word ion. So F minus 1 is a fluoride ion. So let's do a learning check. What is the name of N minus 3 ion? Pause the video and resume once you have the answer. So since nitrogen is a nonmetal, you have to change the ending to IDE. So that becomes nitride ion. In this practice, I will do the first 5 examples, and then you can do the rest on your own. So calcium is a metal. If you look at the periodic table, it has a charge of positive 2. So the ion name is just calcium ion. So hydrogen, if it's a negative 1 charge, you have to follow the negative ion naming rule. So you have to change the ending of hydrogen to IDE, so that becomes hydride ion. If the hydrogen has a positive charge, then you have to follow the positive ion naming rule. So this becomes hydrogen ion. For chlorine, if you look at the periodic table, the top charge is negative 1. So the ion name is chloride ion. For sulfur, if you look at the top charge on the periodic table, it is S minus 2, and that is sulfide ion. So now I want you to do the rest on your own. Pause the video and resume once you have the answer. Okay, so here are the answers. So now that we have a good understanding of naming ions, we're now going to put the rules together to name a binary ionic compound. So this is a setup. We're basically combining the rules for naming cations and anions. So you always write the cation first, then the anion. So let's do a check of understanding. What's the name of the following ionic compounds? Let's start with Kf. K is potassium, and F, since it's a nonmetal, becomes fluoride. So this is potassium fluoride. For CaCl2, Ca is calcium, Cl is chlorine. So chlorine, since it's the anion here, becomes chloride. So this is calcium chloride. Let's do a check of understanding. What is the name of Mg3P2? Pause the video and resume once you have the answer. So magnesium is the metal, so the names can stay the same, and you write the metal first. So 2 and 4 are wrong. P, which is phosphorus, becomes the anion, so that's phosphide. So the answer is choice 1, magnesium phosphide. What is the chemical formula for calcium hydride? Pause the video and resume once you have the answer. So we know calcium is the metal, and it has a charge of positive 2. Hydride is the nonmetal, and it has a charge of negative 1. So in order to figure out the chemical formula, you have to crisscross the charges. If you do that, you get calcium H2. So the answer is choice 3. Now we are going to go over the rules of naming ionic compounds with polyatomic ions. If you recall, polyatomic ions are found on table E on your reference table. So the rules are the same with naming binary ionic compounds, except that the polyatomic ion name stays the same. For example, here we have Na2O2. You first have to identify the polyatomic ion, which is O2. If you look on table E, it is peroxide ion. So Na, which is the metal, the name stays the same, so that's sodium peroxide. So let's do a learning check. What is the name of KOH? Pause the video and resume once you have the answer. So first you have to identify the polyatomic ion. So if you look at table E, it is OH. That is hydroxide. Since K is a metal, it's going to stay the same, so that's potassium hydroxide. So choice 4. What is the name of NH4Br? Pause the video and resume once you have the answer. So first you have to identify the polyatomic ion. If you look at table E, it's NH4, which is ammonium. Since bromine is the anion here, you have to change the ending to IDE. So that becomes bromide. So the name of NH4Br is ammonium bromide. That's choice 3. Learning check number 6. What is the chemical formula for sodium sulfite? Pause the video and resume once you complete this. So first you gotta go to the reference table on table E and look up the chemical formula of sulfite. So sulfite is SO3 with a charge of -2. Sodium has a charge of +1. So if you crisscross the charges, you get sodium with a subscript of 2 and SO3 entire unit has a subscript of 1, so parentheses is not required. So the answer is choice 2. For table 2, I'm going to do the first 3 questions and then you can do the rest on your own. So lithium and chlorine. So lithium is the metal, chlorine is the nonmetal. So the name of the ionic compound is lithium chloride. And for chemical formula, you have to crisscross the charges, so that's LiCl. For sulfur and barium, barium is the metal, so you have to write that first in the chemical name. Sulfur is the nonmetal, so you change the ending to IDE, that becomes sulfide. So the name is barium sulfide, and the chemical formula, if you crisscross the charges, is BAS. For number 3, for magnesium and iodide, magnesium is the metal, iodine is the nonmetal, so iodine, the ending changes to iodide, so this becomes magnesium iodide. The chemical formula, if you crisscross the charges, becomes MgI2. So now I want you to do the rest on your own. Pause the video and resume once you complete it. So here's the answers. For table 3, it's more practice in naming binary ionic compounds and getting their chemical formula. So pause the video and resume once you complete this. So here's the answers. For table 4, you'll be naming ionic compounds with polyatomic ions and writing their chemical formula. So I'll do the first 3 examples and then you do the rest on your own. So the first one is sodium and hydroxide. So sodium is the metal, hydroxide is the polyatomic ion. It's a charge of -1. So the name of the ionic compound will be sodium hydroxide. The chemical formula will be NaOH. For peroxide and potassium, peroxide is the polyatomic ion, is O2 minus 2, and potassium is the metal with a +1 charge. So you're going to write the potassium first, then the peroxide. The chemical formula is K2O2. For number 3, you have lithium and cyanide. Lithium is Li with +1 charge. Cyanide is a polyatomic ion, is Cn with a charge of -1. So the name of the ionic compound is lithium cyanide. The chemical formula is LiCN. So now I want you to do the rest on your own. Pause the video and resume once you complete it. So here are the answers. For the last table is just more extra practice on naming ionic compounds with polyatomic ions. So pause the video and resume once you complete it. So here are the answers. So this concludes the video lesson for today. Remember to do the Junapod homework.